In our previous videos, we talk about how to create a surface using the points obtained from a total station. And then we talk about how to produce a topographic map and how to generate the contours as well. Today we are going to talk about how to put an alignment to a contour surface. So now this is one of the example contour surfaces I have created already, plus the detail of a road. So this is the existing road of the particular section which I have surveyed. And here you see the road, existing road is almost parallel to the contours in the first segment, and hereafter it paints and cuts the contours. So since it's cutting the contours, the gradient in this portion is very high compared to this one. So if we are going to redesign the road, what we can do is we can make the gradient smooth. So we can give a new alignment to the road. So that is what we are going to do today. To give an alignment, what we can do is we can go to the toolbar and find the relevant tool to design that, right? So there are several options in the alignment. So first we need to go to Home tab and then go to the alignment. In the alignment we have several options: alignment creation tools, create best fit alignment, create alignment from objects, and here what we are going to use is alignment creation tools. So when we go to alignment creation tools, there's a box like this, so it will appear, and you need to give the name for the alignment. So this is a design alignment. Design alignment. Right, and you can give the description. The road A at site Naranguda. So this is the survey survey details are from Naranguda. So road A at site Naranguda. Like that, you can enter the descriptions. So those are not very much important. Then you need to think about the design criteria. So here when you click this one, you see the maximum speed given is starting design speed 100 kilometers. So we can reduce it to 40 because this is a hilly terrain and we can't maintain 100 here. So I just change it, and then I go to general description, and here site again you can give. If you want, you can give a name, right? Just like first you can't manually enter this one. You have to define a site before, right? So in this tool space, you can see there's an icon called sites. So you need to first define a site, and then you can load it here and give it. But here none. So then the alignment style, it is a propose, right? Propose alignment, because it is a design and propose alignment. And then labels. So I don't need all the labels, only the minor and major labels. I will put like that, and I can change the settings if required. So I can go and see the labels. So increments, port stations. I can go and see whether I can change the sizes of letters and all those things. Yes, the text heights are given here, 2.54 millimeters. Likewise, right? So we'll keep them as it is and see once the alignment appears. So then we can change them back. They are not suitable, right? So now I'm closing this one. Now we have already fed the required details here, and then I click OK. When I click OK, the toolbox appears like this. So this is the toolbox, alignment layout tools, right? From here we can pick the tools. So what I'm going to do is I'm just going to keep this part as it is, right? So anyway, I'm going to draw the design alignment back. So I'm going to first use the fixed line. So here from this tool, we can pick a fixed line 2 points, right? So now I'm going to start my alignment. I will start it from here. Because I'm going to keep this part as it is in the road, and I'm going to do the design from here. So this is a straight part. I will keep it here. Then here onwards, I'm going to bend my road, right? Bend my road because here you can see a sun bend and going across the contours. I'm going to cut the contours having an angle greater than this angle, because then it is little bit parallel to the contours, but here this is just a little bit perpendicular to the contours. That's why the gradient is high in this part. So now I'm this is another straight portion. So I'm going to end my road here. Now you see I have 3 alignments, 1, 2 and 3. Now what I'm going to do is I'm going to join them. Now here I need a bend, right? I need a bend. So what I'm going to do is I'm going to pick a bend from here, right? So I can draw curves using this tool. So I was in this fixed line tool. Now I'm going to curve tool, right? In the curve tool, I can use this one, pre-curve fillet between 2 entities through point. So this is the most flexible tool I can use. So I'm going to pick it. And then I need to select the first entity. Now I'm going to join 2 entities, right? This straight one and this straight one. So then I have to pick the points, the entities, which I'm going to join as a curve. So this is the first entity, and this is the second entity. Now you see, then now I'm dragging this here and there. Then you see at one point and after one point, right? It is not giving a chance to make a bend, right? But here also I can move it here and here, and after this point it is not practical, right? So according to the design speeds and the design criteria, it is not possible to drag the curve after this point, right? But in this range it can be moved here and there. So I will fix it here. Now you see we had a straight portion up to here, but now there's a bend, smooth bend, right? Not a bend having a higher radius like this, like in the previous existing row. Now then I click enter. Once I click enter, now you see the entire alignment will be aligned like this. So this is the design horizontal alignment of the road, right? Once you have drawn this, your next task is to draw the surface profile. Draw the surface profile of this alignment. What is the meaning of surface profile? Surface profile gives you how the heights vary along this line which you have from the ground, from the drawing, right? So now I'm going to close this one. For that I can go to this profile icon and click it, and here you have several options. So since I have created this alignment in the surface. So I can use this create surface profile option, right? I select this create surface profile option like this. The first one is you need to select the alignment. So alignment is the proposed horizontal alignment. Proposed horizontal alignment is the alignment. So I selected that one. When I select the proposed horizontal alignment, you see the starting chain edge is shown here, and the ending chain edge is visible. And then you need to add this using this at the selected alignment. And this is the the surface which I have created this alignment, right? So I have created this alignment over this existing ground surface. So then I have to click draw in profile view. When I click the draw in profile view, you will see that there's a box appear, which appears like this. In this we need to select the alignment. So automatically the alignment has been selected here as the proposed horizontal alignment. As a profile view name, you can give anything. Say longitudinal section, longitudinal section. That is the name, and you can give the description if you want. In the profile view, you can see the profile view or change the settings of the profile view by clicking this drop down menu and go to edit current selection. And in the edit current selection, we are going to this graph option, right? In the graph option, we can change the vertical scale and the horizontal scale of the longitudinal section that you are going to draw, right? So the vertical scale is 1:100, a bigger scale, and the horizontal scale is 1:1000, which is a smaller scale. And because of these two different scales, you can have a vertical exaggeration like this. Why we need to have a vertical exaggeration? Because you know that when you are drawing the profile in the same scale, you will not notice the changes in the vertical direction, because we know that the longitudinal sections are very lengthy, right? Very lengthy. So therefore, the gradients will not be shown properly in the same scale drawings, right? That's why we need to give a vertical exaggeration here, right? Then it's okay. Then apply OK. Then we need to move to next option. In the station range, starting from 0 plus 00 and ending from 0 plus 157.17. So I'm going to change this, right? I will define it. If it is automatic, it will be automatically selected. You can define it from 0 plus 00. Yeah, I will in my profile view from 155, right? 0 plus 155. That is my range. And then I will move to next option. In the profile view height, right? Automatically it has this minimum value 100.10, maximum 107.16. So I can define the minimum value manually, right? So I will put 99 meters here and 108 meters here. Then next, go to next option. Then it has the display option. I'm not going to change anything here. And this is the set. Select the band set. Band set is the reading set which is shown under the drawing for the longitudinal profile. So it may have the existing levels, the filling levels, cutting levels, right? All the things. Here we can select anything from this list: cut and fill, no band. If you don't need any band, you can select no band, right? E.g. FG elevations and stations, land, desktop, full band set. So we'll select this one, EG and FG elevation. So I'm not going to select this one. Just keep this as this and create profile view. Then I select create profile view and pick any point in the drawing sheet where I need to plot the longitudinal profile. So now I'm going to click here. When I click here, you will see this is the proposed horizontal alignment profile, right? Profile of proposed horizontal alignment. So this is the 100 meter. And this is how it varies, how the height varies. And this is the longitudinal section. So this we have other things as well, but today I am going to only show this existing profile. So this is how it is done. The next thing we can do is let's say now we need to take more details about this horizontal alignment which we have created. We need to first set out this alignment in the ground, right? We need to go to the site and set out this existing alignment on the ground. So this is how it is done, right? Why we need to set out this design alignment on the ground? Because then we can use the level instrument and do cross sectioning and get more details to do the area volume calculations, right? Because this is just a proposed alignment, right? This is just a proposed alignment. Therefore, now we need to set out this on the ground, right? Then we need to set out this alignment. This is how it is done. First, you need to go to points. Point is the tool box that we use to import the point groups into the Civil 3D workspace. So the same toolbox we are going to open from Project Creation Tools, or you can go to points here. You click points here, or you can go to point creation tools. When you go to point creation tool, the toolbox will appear like this. From that one, you need to go to this measure alignment option, right? Measure alignment option. Here I'm going to select this alignment and it asks the name of the surface. So our surface is existing ground, and if you want, you can give the description. Not click OK. When you click OK, it asks the starting station of the alignment as 0 plus 0, 0, 0. If it is OK, you can click enter. Then the ending station 157.17. Is it OK? If it is OK, you can click enter. And specify an offset. So at 5 meters from the center line, you need offsets. Then you can click 5 meters. But I don't need that one. I need only the center line points, right? I put as 0 and enter. And then enter an interval, right? So if you need the design center lines at center points at 10 meter interval, then you can keep 10 as it is. If you need to take 5 meter, then you can 5 meter, 20 meters, 20 meters, right? So since it is 10 meters by default, so I will keep it as it is and click enter. Now you need to enter a point description, right? Point description. So we can say that it is as a design center line DCL, that is the point description, right? Then I have to click enter. So now I will keep entering until the 10 meter point, right? 10 meter intervals will be marked in this alignment. Right now you see I'm going to click enter. Now when I click enter, one point appeared here, that is at the 10 meter interval. Now I'm going to click it back. Now you see this point appear. Now I'm going to click it back, this point appear. Now likewise the points will appear at 10 meter interval, right? You see now here, here. You need to keep entering, right? Not clicking on the alignment, entering. Right. So now these are the points which was created on the line. So now we are going to set out these points in the next day for more details, right? So once you have set out these points on the ground, you can obtain them. You can obtain the heights, exact heights on these points using the level instrument, right? Because these are not exact points. So these heights are generated by the contour map, right? That height may be actually there, but most of the time this height is not there in the actual place, right? That's why we need to get the heights back after doing the setting up. So now I need to get these points to a table. So this is how it is done. So I will close this box. So you need to go to annotate, right? Go to annotate and add tables, right? There are two options: add labels, add tables. From add tables, there are options. Add point table, that is the one that I'm going to pick here. Add point table. Then it asks what is the table format. PNEZD format is the format I need, right? That means point number, nothing, distinct coordinate, set coordinate, and description is the format in the table I'm looking for. So now it is okay to me. Number of points selected, right? Number of points selected. Here there are maximum rows per table 20, maximum tables per stack 3, offset 40. You can change this if you want, right? But since we are having 15 points, the maximum number of rows are okay for me, 20. It is not exceeding 20. If it is exceeding 20, you can increase, right? So now I'm going to select the points from the drawing, right? So this one I'm going to select, this one, and this one. You need to select only the points in the alignment, right? and this is the final point in the line. Right. Then click enter. So now how many points were selected? 17 points were selected. Now I'm going to click OK. Then we need to specify the place in the background to make this table. This is the place I'm going to keep the table. Now you can set out these points. Now you see the elevation is there, nothing, easting, description. There you can change this order if you want, right? So nothing, easting, elevation, and description is there. So this is the height varies, but this height is in the contour surface, right? Not the exact heights. So exact heights have to be taken using the level instrument. So that is what you are going to do the next day after doing the setting out. Right. So that is how we obtain the points from an alignment. So then if you have a built-in kind of thing, this is how it is done. Right. So first you need to go to the drafting and annotation. Let's say you are going to put a building here. Now you see here the contours are widely spaced. Widely spaced means here the gradient is less. So this place is perfect for putting a house. So for this one, I will take a simple house layout of a rectangular house. So here I can straight away draw a rectangle. Yes, I draw a rectangle here. Since the contours are widely spaced, I am going to use this place to put a building. So this is my proposed building. Now I need to set out the corners of the building in the next day, because I need to do the grid survey and find the export heights exactly to estimate the cut fill volumes. For that I need to mark the perimeter of the building in the site. So this is my proposed building layout, right? So your building plan will be inside this. So you need to somehow level the ground or do the stepping if you want to keep the steps, right? So anyway, I need to mark the perimeter of the ground for the building. So this is how it is done. Again, you need to go to Civil 3D option, interface. Once you have changed the workspace to the Civil 3D, first again you need to mark the points manually, right? Mark the point manually in this corner, right? This is how it is done. Go to points and point creation tools. Manual. Now I'm going to manually mark a point here. So you need to enter a point description. So since I have clicked here, it asks the point description. So I will say building point, BD, building corner, O, H, building H. BD is my code. So when I click enter, it asks the specify point elevation. So I have to, let's say you are going to put your building at a level. Now what is the contour level here? 101, right? You are going to put the building at 100.5 meters. So I will enter that one as well, 100.5. Right. Now you see Once I click enter, this point will appear here, right? Then they specify the location for the new point. So I'm going to this one. Once I click that point, just enter a point description. The previous one is also there as a default one. So I will click enter. Then again as the elevation. So 100.5 is the elevation for the building. So when I click enter, if I click enter, the point will appear here, right? Right. And again I need to pick a point here, here, elevation 100.5. So now you have the building corners, right? I think your building should not be a rectangular one like this, but you have to have several different shapes. But now these are the 4 corner points. Now you need to obtain the coordinates of this point. So you have to follow the same procedure. This is how it is done. I will close this box. Again, go to annotate, add tables, add point tables. Now you can give a name. P point number ENEZ format. Display information. So I will keep it as it is. And here also maximum 20. Right, now I'm going to select the points. This one, this one, this one, and this one, and click enter. Once you click enter, 4 points were selected. Then click OK. Now you can place the table anywhere you want. So it was placed here by mistake. I'm going to drag it down. So now this is these are the points that you are going to set out for the next day, of the ground. So these are the corner point coordinates of the building, right? Let's say if you need to put a grid here, the similar way you can draw the grid line, right, by giving offsets, right? Let's say you need to have a grid of 5 meters, you can draw offsets, and this way also you can draw offsets at 5 meters, and at the intersecting point you can add these points manually and get the coordinate and get the table. So I will show you how it is done. Again, go to drafting and annotation, right? First, you need to draw a line. Since this is a rectangle, you need to draw a line. Then click enter. So now line is there. So now you are going to have offsets to the line, right? So this is the option, offset. Offset distance, you need to specify the offset distance. I will put as 5 meters. 5 meters. Then click enter. Then offset object, this one. Right. Now you see this is 5 meters. Again I will do 5 meters. 5 meters. 5 meters. 5 meters. Likewise, you can have 5 meter grids. Right. And this way also you can have 5 meter grids. So this is how it is done. Then go to escape and again draw a line this way to here. Then click enter. Now you have drawn a line here. Now you are going to take the 5 meter offsets. Again you have to go to offset. Now the default offset length is here as 5. So I'm going to keep it as it is, then click enter. Then it asks to select the object. So I will select this one, select down, select down, select down, select down, and this is how the grid is drawn. Right, this is how the grid is drawn. Then you need to get the heights of these node points. So you need to manually put the points at these nodes, right? At these node points, and then you can again create a table. So this is how you are going to manually put the points. First, you need to again switch back to the Civil 3D workspace. And here go to points, point creation tools. I will do it fast and manual points, manual one, select. Yeah. This one. Then they ask the description. So I will click grid, enter. Point elevation you can view, right? If you want, you can view. But say it's 100 and no need to give the elevation because we are going to find the elevation. So therefore I will keep the 0 as it is. Right now when I click enter, that point will appear. Then here again I will click grid, enter, click enter. So now we are going to obtain or create a table similarly, just like we did previously, right? So this is how it is done. Go to annotate, add table, add point tables. So you can say that then you need to pick the points in the drawing. Right, then click enter. Here the maximum number of rows per table should be 35. More than 35 I will keep as it is 40, and click OK. Then place the table wherever you want. Here after I have forgotten somehow to give the name for the code, but it doesn't matter. And these are the coordinates of grid point. So you can take screenshots of these coordinates and go to the field and put the layout of the node points of the grids and obtain the heights of these node points using the level instrument, right, for area volume calculation, right? So that is the end of today's video. So thank you very much for watching this video. Thank you very much for watching this video. Don't forget to subscribe this channel for more of the very latest videos.